Welcome back to part 2 of the printed heart project that I'm doing for my friend's 12-foot tall yard skeleton as a Halloween decoration. Where we left off at the last video was I had gotten the back half of the heart printed, and now I have the front. So I'm really happy with the way this came out. That noise you're hearing is just some loose lighting inside, which we'll talk about in a couple minutes. But I've got the pigtail for the lighting there, where the power supply can be connected. My plan of using the magnets to hold the two halves together worked really well. I'm just holding on to the back of it. The front is locked in place. So once those are tied together through these loops to hang the heart inside the rib cage and position it, it should not have any problems sticking together. When I was talking with my friend about this, I asked him what his plan was to do the actual lighting effect, and he told me that he had no plan, and that if I wanted to take a crack at it, that would be fine. I figured it would be a fun project to do. I haven't done any electronics work in a little while, and I tried to figure out ways to do it just using parts that I had on hand. So the first thing that I needed to do was figure out what lighting I was going to use, because that would kind of dictate the rest of the design. When I went through the parts bin and tried out a couple of options that I had, what I landed on was this 24-volt white LED strip. It's really bright. I've used it on some projects before. So that gave me the lighting choice, and then I had to design the control circuit around that. So let's take a look at what that process entailed. So to start with, we know that we have a 24-volt DC power supply, and we have our LEDs. So what we need to do is figure out a way to pulse the heart to give it a beating effect. Thinking about the controllers that I had available, the obvious choice for me was an Arduino. They're easy to work with. They can just be powered on and then have the power disconnected. It's not like a Raspberry Pi where you have a shutdown, so it'll be simple for my friend to deal with. Going through the Arduinos that I had on hand, I picked this teensy LC. It's simple to work with and has a PWM output that I can use to do voltage control. Knowing that I'm working with an Arduino, I now need to have a 5-volt power supply to power it. So I dug through the parts bin and found an old DC to DC or buck converter, which I've used to take 12 volts or 24 volts and regulate it down to 5 volts. So now I have a programmable way to control the LEDs, but because they're 24 volts and they're going to draw a fair amount of current, I can't just connect them directly to the Arduino. I'm going to need another circuit to do that voltage control for me. What I found was I had an N-channel MOSFET, which I can use as a driver to interface between the Arduino and the LEDs to let the Arduino control the higher voltage for the LEDs. To start with, we'll run the 24 volts into the buck converter. With nothing attached to it, I adjusted the voltage down to 5 volts on the output. Then that goes into the Arduino. We'll take the output from a PWM pin and put that into the gate of the MOSFET, which will let us control the voltage flowing through it. I connect the positive from the 24-volt supply directly to the LEDs. The source, or input, for the MOSFET is connected to ground, and the drain, or output, of the MOSFET goes to the LEDs. So now I have a simple control circuit that will let an Arduino control the higher voltage LEDs. My next step was to find software that would actually do the effect that I want, and I found one online that was really simple, that uses some trig functions to create a sine wave and then just keeps the upper half of the sine wave so that you go from 0 up to a peak and then back down, and then pauses and does that again. I tweaked the Arduino sketch a little bit to change the pause in between the pulses, and I also had to change the pin definition of which pin was the output for the sketch. Once I'd done that, I uploaded the sketch to the Arduino, built the circuit on a handy-dandy perf board, and saw that everything worked. Once I had confirmed that the circuit worked the way I wanted, I moved all of the components to a permanent PCB and got everything mounted. I used OpenSCAD to generate a box with a lid that would hold the printed circuit board. Then I took that STL and flew it into Fusion 360 to put ventilation holes and mounting bosses, as well as a hole where the cables could enter and exit, printed that out, and put everything in. So now I have the other half of the equation. I have a simple wall wart that I can plug in to an extension cable that goes into this control box that has the circuit board with the Arduino in it. And then that just comes out to an output connector that can plug into the heart. And when it's powered up, it looks like this. So that's the design and construction pretty well finished. I have to do the final mounting of the LEDs inside the heart after I talk to my friend to make sure that it's going to give him the exact effect that he wants. I can go in and tweak any of the programming in the Arduino if he wants it to look different. But the next part of this video series will be me bringing it over to his house. We'll get it installed in the chest cavity and take a look at it at night. So I hope you've enjoyed watching so far, and I look forward to bringing you the next step soon.